Alright, let's talk about something that sounds like it's straight out of a sci-fi novel, but is actually buried right beneath our feet, or rather, beneath the ocean floor. Imagine a type of ice that can catch fire. No, I'm not making this up. It's called methane hydrate, and it's one of the most fascinating and paradoxical substances on our planet. Personally, I think what makes this really interesting is how it challenges our assumptions about what's possible in nature. Ice that burns. It sounds like a contradiction, but it's real, and it's got me thinking about the bigger picture of resources, accessibility, and the limits of human ingenuity. Here's the deal, methane hydrate looks like ordinary ice, but it's anything but. Inside its crystal structure, it traps massive amounts of methane, a highly flammable gas. If you were to hold a lit match to it, the methane would ignite, giving it the nickname fire ice. What many people don't realize is that this stuff is everywhere, under the seafloor of nearly every continent, often in quantities that dwarf conventional gas fields. If you take a step back and think about it, this is both mind-blowing and frustrating. We are sitting on what could be the largest untapped energy reserve on Earth, and yet, it's practically out of reach. From my perspective, the most intriguing part of this story isn't just the existence of methane hydrate, but the conditions it requires to form. It thrives in places where cold temperatures and high pressure meet, like deep ocean sediments or under Arctic permafrost. The water molecules create a cage-like structure that traps methane instead of letting it escape. It's nature's way of storing energy, but it's also a reminder of how precarious these systems are. If the pressure drops or temperatures rise, the methane is released, and that's where things get complicated. One thing that immediately stands out is the sheer scale of this resource. According to the U.S. Geological Survey, the amount of carbon locked in methane hydrates is roughly twice that of all other fossil fuels combined. Let that sink in. Twice. But here's the catch. Most of it is buried so deep, or in such extreme conditions that extracting it safely and affordably is still a pipe dream. Keith Kvenvolden, a geologist who's studied this for decades, put it bluntly, while some production might happen in easier-to-reach areas like permafrost, the idea of tapping into vast ocean deposits. In his opinion, it's just not going to happen. And that's the part that fascinates me, this abundance that's essentially locked away. This raises a deeper question. Why does it seem like the biggest reserves of anything are always the hardest to access? It's not just methane hydrate. Take Titan, Saturn's largest moon. It's got hundreds of times more liquid hydrocarbons than all of Earth's oil and gas reserves combined, but it's 1.5 billion kilometers away, and there's no oxygen to burn it. It's like nature is playing a cosmic joke on us, dangling these resources just out of reach. What this really suggests is that abundance and accessibility rarely go hand in hand, whether we are talking about the ocean floor or another planet. But here's where it gets even more interesting. Methane hydrate isn't just an energy story, it's a climate story too. If you've been following climate science, you know methane is a potent greenhouse gas, far more powerful than carbon dioxide in the short term. James Kennert, a climate researcher, points out that certain areas, especially in the Arctic Ocean, are particularly vulnerable to destabilization as ocean temperatures rise. If those deposits start releasing methane, it could create a feedback loop, accelerating the very warming that triggered the release in the first place. A detail I find fascinating is how this highlights the difference between a comforting narrative and the messy reality. It's not a ticking time bomb everywhere, but it's also not something we can ignore. If you ask me, the real lesson here is about perspective. We are so used to thinking of resources as something we can just grab and use, but methane hydrate and Titan's lakes of methane force us to confront the gap between existence and usability. It's like having a treasure chest with no key. And honestly, I think that's a metaphor for so many things in life. How many times have we looked at something and thought, if only I could access that, whether it's a resource, an opportunity, or even just time? The harder problem isn't always finding the treasure, it's figuring out how to get to it without causing more harm than good. So, what's the takeaway? For me, it's this: methane hydrate is a reminder that the world is full of paradoxes. It's a resource that's both incredibly abundant and practically unreachable, a climate risk that's specific, but not universal, and a scientific curiosity that challenges our assumptions. It's not just about the ice that catches fire, it's about what that ice represents, the limits of our reach, the complexity of our planet, and the questions we still need to answer. What do you think? Is methane hydrate a game changer waiting to happen, or just another locked door we are better off leaving closed? Let me know in the comments.